Hey guys, today we're going to do Chapter 9, Section 9, which is on natural logarithms. So we've been talking about logarithms, and now we're going to talk about a specific kind of logarithm, which is the natural logarithm. As we know, common logarithms, those are our logarithms where we don't actually have to write a base in, and instead we just have a base of 10. Well, a natural logarithm is pretty much the same thing. The only difference is that now we have a base of e. So we've talked about the number e before when we did our compound interest formulas and our PERT formula, so PE to the RT. Remember, that was your continuous compounding formula. So we're using that same e value, and we're using that as a base for our logarithm. So we've seen in the previous sections many numbers can be the base of a logarithm. A special type of logarithm with base e, which is for the exponential function, is called a natural logarithm. So log base e of x, instead we write ln of x. So that ln stands for natural logarithm. By definition, we can say that y equals the natural log of x if and only if x equals e to the y. So if I go through and I want to rewrite these in exponential form, e to the third equals 20.1. Well, I can just write that as the natural log, which has a base of e. So the natural log base e of 20.1 equals 3. If I do that over here, I've got the natural log, again, that's base e, of 0.368 equals -1. Okay, if I go over here, I've got the natural log of 12.18 equals 2.5. Okay. Now if I want to rewrite these in exponential form, I'm just going to do the opposite. So here I've got a base of e, so this would be e to the 5.58 equals 264. This would be e to the 0 equals 1. And this would be e to the 2.3 equals 10. So the same rules that apply to our other logarithms apply to natural logarithms. They're really not any different than other logarithms. The only difference is that now we have a base of e. So the same rules apply. We've got our natural logarithm of 1 rule. So that says the natural logarithm of 1 equals 0. We also know that log base e of e to the n is equal to n. So again, if you were to rewrite that, that would be e to the n equals e to the n. So they're the same thing. We've got our product property, so if I'm multiplying inside of my logarithm, I'm adding my logarithms together. We've got our quotient property. If I'm dividing inside of a logarithm, I can split that up into a subtraction of 2 logarithms. And we've got our power property of logarithms, which says that if I'm taking this logarithm inside to a power, I can move that down into the front and change it into a multiplication. We also know that the natural log of x is equal to the natural log of y if and only if x equals y. So in other words, if you have something like this where you've got the natural log of something on both sides, you can just get rid of that natural log and you can just get x equals y. So let's do some solving here. The first equation I have is the natural log of 12 minus the natural log of 2 equals the natural log of x. Well, if I want to combine that into a single logarithm, I know that they're being subtracted right now, so I can use my quotient property, and that'll become the natural log of 12 divided by 2 equals the natural log of x. So this simplifies to the natural log of 6 equals the natural log of x. And then using this property here, I know that I can get rid of those natural logarithms, and I can just say that 6 equals x. All right, over here I've got 50 times the natural log of x equals the natural log of 6 equals the natural log of x. So looking at that formula there, what I can do is I know that using my power rule, I could move this back up as a power. So this is going to be the natural log of 6 to the 50th equals the natural log of x. So now that I've got a natural log on both sides, I can get rid of that natural log and I can just say 6 to the 50th equals x, which is 8.08 times 10 to the 38th power. So it's a big number. Okay, over here I've got the natural log of 15 equals the natural log of x plus the natural log of 3. So since I'm adding those two logarithms together, I know that I can combine that into a multiplication. So that would give me the natural log of 15 equals the natural log of 3x. Since I have a natural log on both sides, I can get rid of those and I can just say 15 equals 3x, and that gives me x equals 5. And that's everything for your Section 9 notes.